Everybody.
Did it go out?
All right, good evening, everyone. Welcome to Amateur Astronomers Incorporated, also known as AAI, where we have our weekly presentations here at Sperry Observatory in Cranford, New Jersey. Our presenter this evening is AAI member Al Witzgall, who's been a longtime member of AAI, over 50 years, which makes him 29 years old. And the title of his presentation this evening is Small Bodies of the Solar System. And with that, Al, you can take it away.
Okay. Thank you, everyone. Thank you for coming. And welcome to Sperry Observatory. Tonight, we're going to be talking about the part of the solar system that most people don't really hear that much about. Everyone's familiar, of course, with the sun. You're standing on a planet as it is. There are at least 8 others or so more, and quite a bit other of tiny objects comparatively. The small bodies of the solar system, which is our title, of course, asteroids, Apollo objects, comets, Trojans, NEOs, and PHAs. We're going to be talking all about this stuff, though. The last 2, by the way, near-Earth objects and potentially hazardous asteroids. We really don't want to have, for example, what happened to the dinosaurs happened to us.
I want to do something for you. I want to hide this because then it's going to interfere.
There we go. Okay, so we're going to be talking all about these little rocks that are running around the solar system, and hopefully maybe we can learn a little bit from them about the origin of the solar system as well, and maybe what will happen in the future. So let's move along. So it's always good to start with the definition. What is an asteroid? An asteroid is a small body. It's usually composed of rock and or metal, usually iron, which orbits the sun. They're considered to be remnants of the solar nebula that form the planets. Most asteroids are found in the area between the orbits of Mars and Jupiter. And the photograph over here is an asteroid called Asteroid 25143 Itokawa. The number refers to the order of discovery. Already you can see we've got quite a few objects, and we go much beyond the 10,000s level. Now, how many asteroids are in the solar system? As I had just implied, several 100,000 have been discovered and given provisional designation so far. That means we see them, we're able to track them and give a proper orbit to them so we can formally call them part of the solar system, and we can keep track of them if necessary. Thousands more are being discovered every year because we have better telescopes, better technology, and the better the instrumentation, the more we see. So asteroids range in size from little pebbles, really, to about 578 miles, about 930 kilometers in diameter, like the first asteroid discovered, and we'll talk about this a little bit, one Ceres. At least 16 of them are over 150 miles in diameter. Some of them even have orbiting moons. Okay, so here's the largest asteroids chart so far. Essentially, the one I just mentioned before, one Ceres, diameter is about around 600 miles, so 1,003 kilometers. It was found January 1st, 1801. How do you like that? New Year's Day, on the first day of the new century, by PHAs. 2 Pallas followed in close order. Matter of fact, 2 and 4 Vesta all came in there. Pallas itself is roughly about 600 kilometers. Vesta, which is actually a favorite of mine, we'll talk about that later, 538 kilometers. And various discovery dates, as you can see, this guy Olbers was very big on discovering asteroids too. Then 10 Hygeia and 31 Epeirocene. All of these came rather quickly. The whole idea was that at one point someone had said that the solar system has a kind of a pattern to it, and they believed that maybe you could predict where other planets were, because if you had this particular object and this spacing relative to the Earth, you will be able to predict if planets are out there. And sure enough, one of them seemed to just be in the right place at the right time. But then when they looked at it, it seemed very, very tiny. Now, the gentleman who discovered the planet Uranus, William Herschel, said, okay, well, they're star-like, so we'll call them asteroids, or aster for star, oid-like. So there we are. And the name is stuck ever since. Okay, so who found the first one? Again, as I mentioned, January 1st, 1801, this gentleman in Palermo, the Italian astronomer Giuseppe Piazzi, discovered the first and the largest asteroid, 1 Ceres. Okay, now I mentioned before, some of these have moons. This object is 243 Ida and its satellite Dactyl. Dactyl is about a mile across, while the main asteroid, Ida, is about 35 miles long by 15 miles wide. This is a real surprise. When the Galileo spacecraft flew by it, they expected to see the asteroid. And then they found this little guy here, and it definitely was gravitationally locked to it. Maybe it was a piece that chipped off it from an impact. As you can see in the picture, there are some craters all over it, so maybe this is a little chip off the old block here. Now we got some strange stuff out there too. This is asteroid 25143 Itokawa, one of the oddest looking asteroids, not by my definition, but by everybody's. 3 miles long, no visible craters, and it probably is a rubble pile. In other words, all this probably broke up, something hit it, and then gravity slowly but surely put the pieces back together. Might be interesting though to get something on there to take a sample. Okay, so what are they made of? And there are 3 major types of asteroids. The C type that have carbon, carbonaceous, made of ancient carbon silicates. S type, which is silica, and that's most of them, by the way, made of stony silicates and iron. And then M type, not quite as common, metal rich, mainly nickel iron. And this is from my collection. I collect meteorites. Some people go for butterflies, some people go stamps. I go for rocks from space. You know, it's one of those cool things where, you know, you're looking at the moon and then you're holding, not this type over here, you're holding what's called a lunarite, yeah, as in moon. And in effect, you're touching the moon as you're observing it. So yes, you can find them. In case anyone's wondering, you go on eBay or you just shop on there. Yeah, go on eBay, you name it, it's on there. And you will find there are a number of very reputable people that have been collecting them themselves, and the chips from when they're doing their work, they put on eBay, and it's not too bad. I mean, normally from commercial dealers, for example, if you had a 1 gram, 28th of an ounce of lunar material, you can expect to pay in most of the dealerships and minerals upwards of $1,000 a piece. Sometimes though, you can get them because the guy's cut it off and he's already made his money, so he just wants to get rid of the stuff so he gets some new material, and you'll get discounts, so you'll bid for it. And I've done that a couple times. At home, I didn't bring it in. Don't go buy forget about going by my car. It's not in there. I don't have them in there. They're locked up at home. Sorry, kids. But they are quite expensive, and you have to be a little careful about it. I've been lucky. I shop around, as they say, that your mama told you. Well, this is a C type. This has a lot of carbon in it, and also in certain cases, amino acids, which in the right conditions might have life arise from it. It goes into the right conditions on a given planet. Okay, now where are they located? It's the area of the solar system between the planets Mars and Jupiter is where the greatest population of the asteroids can be found. You can see it's pretty cool. And I have some names here that are at Hidalgo. There's Jupiter. And we're going to be talking about the Trojan asteroid, as well as the Greeks and the Trojans, as they're calling it, in a little bit. We have a probe going out there, which we will talk about later. Okay, a little bit of a mission update. Many people might have heard of a probe that went to an asteroid. That is the asteroid there. That is the asteroid Bennu. OSIRIS-REx was a spacecraft that went out there and actually took a sample. And I believe it's September 24th in the Utah desert, there's going to be a return capsule. We'll talk about that in a few minutes, where they took a sample from this object and we're bringing it back. It's going to be pristine. It didn't sit on the ground like they do sometimes in the hot deserts of Earth or in Antarctica. 2 places where you can find these in some abundance. This is pure, and we will find out exactly the composition without having to worry about extracting materials that Earth would have put on had it hit the ground. Okay, and this is cool. This poor spacecraft went out there for about 2.5 years using an ion drive. Yes, it's real. It's not science fiction, folks. And swings into orbit, and to their surprise, Bennu, the asteroid, was throwing rocks at them. We think what happened over here is that the thrusters might have lodged out. So the gravity there, if you weigh 100 pounds here, you weigh something like about 12 grams, not even a third of an ounce, with however weak gravity you have there. So a little bit of thruster, next thing you know, it's throwing rocks at you. Okay, and sampling an ancient rubble pile. This is the sampling on tag sand that it's referred to. And you can see it goes in. These are only 2 frames of about a 10-frame movie. But essentially, after it goes straight in, it looked like it wasn't going to stop.
Okay, but we need more area to work with. Yes.
Yeah, I think this table's not too bad tonight.
Okay.
See, when I left yesterday, I noticed there was like lettuce under the table.
Yeah, somebody
Okay.
else.
I felt bad. It's like, ooh, I should let her get that earlier. Didn't know it was there.
George?
John, turn off your mic.
It always seems when this guy plays with this stuff, there's always something. Oh, well, not his fault. I wouldn't want to have salad either. Anyhow, Tag Sam collected in this area, a place called Nightingale. They gave names to these. And essentially, they got a sample. It was not quite as much as they thought it would be, and yet it filled it to bursting. So Tag Sam, as it was called, did its job, and maybe a little too well, because if you notice, we shouldn't be seeing this. We should be seeing this black, because there was a mylar shutter. And look at all the particles around it. This movie, they're losing their sample. What they wanted to do was have this close out, ideally, close the container, and then spin the vehicle. They knew the mass of the spacecraft that went out there, and what variation would tell them from that would imply how much material was grabbed. They could contain up to about 4 pounds. We believe, because of all this stuff that blew out the door here before they got it packed away, there's about 200 to 400 grams, half a pound to about a pound of material, which we will get back, and we'll be able to finally understand this asteroid a little bit better. So the whole idea was, quick, pack it up. This is the Tag Sam container, and they're about to close the lid on this. This has a heat shield on it, so when it hits Earth's atmosphere, it will not burn up, and it will cushion it. And there we are, return of samples. Hopefully, everything works out right. September 24th, 2023. It'll come down to the Utah desert. If we're lucky, it'll look like this when it reaches from another experimental package. And they will go over to it. They'll pick it up, put it under very special conditions. A laboratory has already been prepared for it in Houston, the old lunar receiving lab, now the lunar sample lab. And I think they've been a separate one specifically just for this particular object, this material. So we're going to have a lot more information for you, I hope, in about a year. Okay. Now, when you saw the overview, you saw the Trojan asteroids. Trojan asteroids are asteroids that orbit in gravitationally stable Lagrange points. He was a 19th century astronomer and physicist, and he realized that Jupiter and other objects, even the Earth, have stable points in its orbit where you can put something there and it'll stay there, balanced between the sun, the planet, and the object. So these apparently are in the Lagrange points, either trailing it or preceding it. Preceding Jupiter would be the Greek camp, as it's called, and the Trojan camp, which follow. It's all because the Greeks won the Trojan War. Okay, the largest that we've seen so far is called Hector, discovered February 22nd, 1906 by this gentleman here, German astronomer Max Wohl. Now, just recently, in 2006, Scamangios discovered those 6 orbits in about 16 hours. You're seeing here the overexposed picture of the asteroid, and here's its moon, or at least a component of it. This is really cool. Okay, there we are. Now you can see Jupiter commands where the asteroids go about, and this is another asteroid which apparently is associated with the Trojans. And Jupiter has the most of them. The ones, again, as I mentioned, Jupiter and its orbit, named for Greek heroes. Those that followed it were named for the Trojan heroes. So, okay. Now there's a spacecraft going out there. Usually when you have a spacecraft in recent years, you have an abbreviation made to get OSIRIS-REx, for example, was one. In this case, it's Lucy, but it's not named for the song Lucy in the Sky with Diamonds, which everybody thinks of, and I don't blame them. It's named for Lucy, which was one of the first hominid beings that was discovered as a fossil about 4 million years old in Africa. And that shows us where we evolved eventually from. She was considered to be an explorer. Maybe that's what happened to her, that she explored the wrong place. We don't know. All we do know is that her relatives left footprints all over Africa and eventually evolved. One of the best ways to get an animal of any kind to evolve is to put it under stress. So if you got lions and you've got snakes and you got crocodilians and all sorts of stuff like this, you're going to evolve or die. Luckily, we evolved. We learned. And now we're sending spacecraft out. So Lucy is now the NASA spacecraft on a 12-year journey. Should be launching very soon. Visiting 2 main belt asteroids as well as 6 Jupiter Trojans, maybe more. This is long term. We're talking in the order of about a 12-year mission, maybe even longer. It's a big spacecraft too, because we do not have nuclear power on this. Everybody thinks nuclear power, and they think, you know, of Chernobyl and of course Hiroshima and Nagasaki and all sorts of stuff like that. Fujikawa. The thing is, that's where the engineer failed. We have had spacecraft, actually for military, that were launched on a Titan 3E, which was one of the most powerful rockets we had in the arsenal, if you will, just to be launched. The thing blew up. They found the nuclear power pack. The only thing that was wrong with it is that the paint burned off and the wires burned off, but there was no leakage. And but they said, you know, maybe we should be a little more careful with this stuff, which is undoubtedly correct. So Lucy's solar powered. So her wings, if you will, are 51 feet across, gathering up the sunlight. Because you got to remember, Jupiter is out there. We are 1 astronomical unit, 93 million miles. Jupiter is 5 times that away. So the light is 1/25 of what we have here on Earth. Maybe a very, very dark, dismal day is very close to it. So we have these huge solar panels. So they allow us to be able to use the solar energy that's out there. And as you can see, we will be going out a first asteroid encounter here in 2025. It'll go out. Yeah, that's right. It'll go out here. It'll vector around the sun at least once. Earth will assist it and throw it out to Jupiter. It'll be arriving in 2027 to 28 and exploring at least 2 main belt asteroids as well as 6 Jupiter Trojans. So we're going to see what happened. We may have leftovers of the early solar system waiting for us out there. This is an overview. I love this picture. I only found this today. This is supposed to be a hypothetical Trojan asteroid. And here it is getting ready to explore it, at least remotely. It's not going to land on it. These are the other objects that will go to. The first one's going to go to in April 2025. It's Donald Johanson. He was an asteroid and minor planet specialist. Passed away a couple years ago. And it was named for him in honor of his work. There'll be other objects, too, that this is going to be doing a flyby. And we will get more information about those old asteroids out there. At least we hope so. Okay. A little closer to home, and maybe uncomfortably close to home, NEOs, or near-Earth objects. They're comets and asteroids that have been nudged by gravitational attraction of nearby planets into orbits that allow them to enter the Earth's neighborhood. Lucky us. About 30,000 are known. They're composed mostly of water, ice, and some dust particles and such. And that's all well and good and such. And sometimes these particles hit the Earth's atmosphere. They're very tiny, and they form the meteor showers. The Perseid meteor shower just recently, about a week and a half ago. We didn't see any when we were up in the Telescope Makers Convention up in Vermont about a week ago. But other people were going, "Oh, there goes another one," back and forth after midnight. The summer meteors, they're called, for example. Okay. This is facts about NEOs. They're a convenient opportunity to study small worlds at much less cost than missions beyond Mars orbit. And that we think that they are fairly pristine samples of the early building blocks, the planetesimals that built the planets. We may have secrets waiting for us what happened when the solar system was forming. This is how it looks when you have a very large telescope and you take 3 photos about the same area. Anything that's moving ain't a fixed star. Okay, and how common are they? Small near-Earth objects collide with the Earth on a daily basis. We call them meteors. Fortunately, as they get bigger and bigger, there are fewer of them, so a collision with a really large one is pretty unlikely. It's one of those things that you read about this. You probably already heard about what happened in 1908 in Tunguska, Siberia, where something very, very large hit with the force of a 50 megaton bomb that had hit a city. Another 6 hours, I believe it would have came very close to Paris because the Earth rotated to it. Luckily, it was in the middle of the taiga, the forested areas of northern Siberia. Although something like 15,000 reindeer disappeared, vaporized. So it's these are not to be trifled with. It's called that particular meteorite. It's called Sikolte Elin, named for the nearby town. Luckily, we don't have many of those. We're very fortunate. We haven't had a major. In fact, funny thing is, 1908, we had that, and then about a little over a century later, another one also in Siberia, but of a different kind of material. That one was meteoritic metal, iron nickel. Another one that landed near Chelyabinsk. Well, let's put it this way: it was about, I don't know, 500,000 feet up, and the shock wave from it coming in and exploding actually leveled a couple buildings. Some people got hurt, nobody was killed, but they found little black materials when they opened it up. They found it was very fragmented inside. So that tells us something of the conditions that had happened to it was out in space. Now, luckily, they're rather rare. You have a better chance of hitting the lottery in New Jersey twice within 10 years than having one of these hit your house. It did happen just recently down in central Jersey. Had a rock about the size of your hand. And apparently it was rather warm. I've always heard the statements that, well, when they hit the ground, they're fresh, they're hot. And no, they're not. Most of the time, they're actually cold, and we're mistaking sudden cold for being hot, and they drop the rock, of course. This one came in, and it was indeed warm, and it bounced around. Nobody got hurt. The ceiling took it. But other than that, it was pretty good. And I'm saying to myself, I think they had this 8-year-old boy, and I'm saying, son, you got yourself your college money there. So, the meteorite itself is called Titusville, I believe, which we name these for the nearest geologic known position, usually a postal office. So the nearest one that served their house where this landed. The object itself was about that big. If you type in New Jersey meteorite 2023, you'll get a nice, beautiful set of pictures of it. But as far as these other guys, though, they're relatively rare, and we keep track of them. So no, you can all go to bed knowing that you don't have to have a catcher's mitt when you're going for something. Okay. Well, do they reach Earth? Yes, they do. This is a plot that was done, declassified, about not quite 10 years ago, showing where many of these air bursts, if you will, when they come in, they blew up in the Earth's atmosphere. So look at some of the larger ones, though, here. Look. There we go. Look at the large ones over here. This is the amount of energy in gigajoules. In other words, this is approximately a megaton. There are very few of them, but they do happen. Most of them, thank heavens, out over the ocean. So you get some very surprised tuna. Okay. Others here, I've mentioned before, Apollos are Earth-crossing asteroids with orbital period longer than about a year. There are over 17,000 of them that are known. And here we have a little bit of trick photography over here. Same area, but exposures every minute or so, and you can actually track out the path across the sky. In the Apollos, there are Atens and Apollos and others. These are guys that come in from the asteroid belt and usually crossing our orbit. Okay, 1620 Geographos. It's an irregular body, one of these objects that move about. for the Apollo group, with dimensions of roughly about 3.2 miles by 1.2. It's named for the National Geographic Society. See, they supported back in the late 40s and early 1950s a northern sky survey, which is used by observatories all around the world. So in honor of their funding, it got named here. Geographos, by the way, means mariner or explorer. It is classified as Earth-crossing asteroid because it can evolve eventually to intersect our orbit. But right now, it's rather calm and friendly. It's not going by us. The distance of 0.8 to 1.7 astronomical units. 1 AU is 93 million miles. And it does this once every 508 days. Okay. Then potentially hazardous asteroids. These are the ones that keep me awake at night. The PHAs, if you will, PHAs, are currently defined based on parameters that measure the asteroid's potential for getting threateningly close to the Earth. And this is actually an impact, an asteroid that has been impacted by one of our spacecraft. And you can see it's a rather nice affair. You don't want one of these objects hitting the Earth. How many are there of these dangerous ones? Roughly about 1,258 so far as of January. I haven't heard the new statistic yet. And some of these get very close. You can see they're relatively big, 150 meters. So you wouldn't want this in, say, in a harbor near your town, because when a crash lands, you can have a tidal wave. And how dangerous are they? Well, the number of actual cases found that have had any considerable damage in the next half century is relatively small, only about 4 that we're watching right now. And it shouldn't be any surprise further observations might even eliminate these. So we can all turn the light out and go to sleep. Comets, everybody's favorite, really, and yet years ago, not too long ago either, in 1910, when Comet Halley came around, somebody let it be known that the comet had some dangerous gases in it. But before we get to that, let's talk here basically. The comet is a leftover from the creation of the solar system. They're made up mostly of frozen water and gases that travel around the sun along elliptical orbits. When a comet approaches the sun, it starts to sublimate. It goes directly from a solid to a gas. And the gases and dust form an ion tail from the action of solar radiation and a dust tail from particles and minerals trapped in the ices of the nucleus of the object. These things are amazing things to see. Till only recently, people would look at them as being harbingers of doom and destruction. 1910, Comet Halley was on one of its return trips. And there is a legend that there was a Midwest village that were going to sacrifice a young girl to try to save the world. Luckily, the sheriff got there and stopped the nonsense. But there were people that were truly worried about it. See, the problem was they got a spectrum of it, and they saw a cyanogen, CN3, that does create in water cyanide or cyanic acid. If you mix it with sodium, you have sodium cyanide, one of the most powerful poisons known. So they say, oh my God, we're all going to die. We're going to have gas in all of the atmosphere. Well, it never happened. Earth didn't even go through the tail of the darn thing, and there was nothing there. So this does happen now. Just recently, when we had another comet, you'll see a picture of it in a few minutes, called the Comet Hale-Bopp. There was a group of misled people who believed that there was a UFO following the comet. Yeah, I know, but this gets deadly serious because their misleader said we all have to get ready for the ascension. So they had to take they all had, talk about cyanide, I believe it was potassium cyanide, and they all lay out there, and finally somebody went up there and they found, like, I think it was around 40 people committed suicide for no darn good reason. And there was no UFO following Comet Hale-Bopp. The picture they got was of the comet, but there was a bright star nearby and it caused a photo defect. Talk about stupidity. It's really, really amazing, even in this day and age, an enlightened period. But anyway, this has happened throughout history. You go back in the Bible, you look back at, I think it was the young before King David, hiding himself on the threshing floor of Thebes from the witness of the object in the sky. But it turns out that comet came back in 1997. Okay, so before we get to, I'll leave you hanging for a little. Okay, there are two places that basically are the origin point. The Kuiper belt, which is out just between Neptune and Pluto, maybe a little bit beyond that. It's because of the Kuiper belt that Pluto, for a while at least, got demoted from being a real planet to a dwarf planet. I mean, when it grows up, it'll become a planet. This is so stupid. Well beyond that, well beyond Pluto's orbit, there's a region called the Oort cloud, named for Jan van Oort. We theorize that that's where this reservoir of long, very long period, 1,000, 2,000, 5,000 year comets came from. And it turns out it seems to be about right. And we have billions of these things all over the place. Again, leftovers from the creation of the solar system. I guess a couple bright ones. Okay, I'm going to toot my own horn for once. These are photos I took over the years. Comet West was my first great comet, if you want to call it great. You had to get away from the city lights, as you might have expected. This was taken on March 7th of 1976 up in Voorhees State Park. There's an area there called the Overlook. And my friends and I from AAI and NJAA got out there at 3 in the morning, and we are freezing ourselves to death. But we all got, some cameras froze up too, because remember, we're still using, anybody ever hear of something called film? Yeah, we still had that. And some of the cameras broke. Some of the film broke. I got lucky. I did an old trick that I learned and saved my life a couple times with taking photographs. I took my camera, before I set up the photograph, I put it inside my coat. It was enough to keep it warm enough. And we're waiting for the comet to rise. So here we are sitting there, and suddenly we remember there's an airport down beyond the tree line here, outside the park. I said, oh no, because look at this. You have this floodlight coming up through here. And I'm saying, good grief. But some people started actually shutting down their equipment, and then suddenly it detached itself from the horizon. That is Comet West. When we saw it that morning, we had a window between snowstorm and snowstorm. That was the only morning we were able to get any kind of good photos of it. This object will be back in, I believe it's 75,000 years from now. So we were I considered doing astronomy to be almost a privilege. And this was. And I'm looking at this, even now, this is taken, folks, if you remember your old film, Tri-X black and white. My buddy Jim Flood was still in high school, and he had access to a dark room. And so I didn't have to worry about somebody saying, hey, you don't got anything on there, kid. Well, it turned out we had a whole bunch of these images. And I was very surprised and happy to see that work. We flash forward 1996, about the same time, a little later. This is Comet Yakutat. It's a scary thing about this. First off, the good news is you can see the comet. By the way, this greenish color, that's real. It's not the film. Turns out there's ionization going on in here from solar radiation. Forming the tail, the gas tail, this blue guy over here. And you can see it better as the dust tail over here. But there's a little dust tail extends out to about here. This is one of the longest tails that any comet in history had been recorded, over 100 million miles long. Stretched all the way back from the Earth, from Earth's orbit, halfway into the asteroid belt. And you can see it's a little bit of trailing over here. This was I can tell you right now, 1600 speed film color. They don't make it anymore. Ektachrome 1600, I miss it. And this tail extended off the film, if you will. So I was looking at a 65-degree tail, and it still had another 20 to go. I'd gotten the whole thing, and I didn't have a short enough focal length. Still, I got it. Then in 1997, remember I mentioned about a future King David hiding himself from the symbol of God in the sky? Well, this comet came back about 4,000 years later. And on the morning of February 8th, 1997, Bonnie and I, my wife, came down here. We drive in, and I look over. It was beautifully clear, cold morning. And we saw this little bright object where there shouldn't have been an object. I said, oh my gosh, we got a monster over here. I get into the 24. I slapped my camera, still film, in to the eyepiece holder and got this picture down at the bottom. Sometimes in older drawings, they show what they call hoods. Well, I caught those hoods. It turns out that's materials vaporizing out. It comes out, gushes out, then the solar wind, the energy and particles coming off the sun, pushing it back to form the tail. I got lucky, to be honest with you. I didn't expect to get this. Then about 2 months later, 2 months minus a day, this is what comet tail pop looked like. You see a beautiful dust tail through here, and this gas tail, which is glowing in the radiation of the sun. Absolutely beautiful. It's one of those things that, you know, you keep in your memory. You may forget your name. You may forget, you know, because Alzheimer's and such, but this you're going to stay with. You'll remember this. I certainly do. I certainly will. Okay, now coming next year to an observatory near you. Gee, you're in an observatory. Hey, great. Okay. I'm going to destroy the name, and I apologize to anyone who speaks Chinese. C Comet C 2023 A3. In other words, the third comet in the first 2 weeks of this year. Let's see, Sushinshan Atlas. The Purple Mountain Observatory and the Atlas Sky Survey detected a comet named, as I tried to pronounce here. This is expected to hit naked eye visibility in October of next year and become bright enough maybe even to be seen in daylight. Last time that happened was Comet Hale-Bopp. Okay, these are the discovery photographs, and you can see the motion of the object here. It's very far away in these pictures, but it's coming in. So keep our fingers crossed. Although I must confess that there's an old saying with comets, you got to bet on something, bet on a horse, don't bet on a comet. Because we've had duds over the years. I don't know if anybody here is old enough or had read in the history books, Comet Kohoutek, back in the early 1970s. This is going to be the comet of the century. It was found all the way past the orbit of Saturn. When it comes in, it is going to light the sky. We astronomers will be able to demand that the universe and people bow to our will. Didn't work that way. Didn't work that way at all. It's a little smudge in the evening sky in early December, but it's a comet. They can be unpredictable, and maybe this will be too, or maybe it'll light up the sky and you'll see it on the cover of National Geographic. Okay, so who knows? Maybe October 14th, and Betty, it'll be fading out, but by the time November 7th comes in, it'll be nice and high. About 90 minutes after sunset between this period. A pair of binoculars probably will show you the little fuzzy guy out there. And of course, if it turns out that I'm wrong, it turns out that the thing is very bright. I will come back up here, talk about this particular comet, and I will apologize for underestimating it. I hope I'm wrong. I'd like to see the thing light up the sky. Okay. Now, how many people were thinking of maybe going to the eclipse that you've heard about coming up next April? I see hands. Okay, a couple people good. Me too. Can't wait for this myself. Well, during the total eclipse of April 8th, 2024, this is not going to be here. The path of totality does not go over Cranford. I wish, but you can get out to you can go out to Texas, follow the path. We're gonna have a lecture on that probably about a couple months, 2-3 months. January, yeah. When we'll have all the information, I'll have packets and stuff, how to photograph it. You can do it with a smartphone, folks. So it's possibility we'll have the total eclipse over here be, or I'm hoping to go to in Marion, near Marion, Carbondale, Illinois. That'll be about 4 minutes and 12 seconds, which is pretty good for a total eclipse of the sun. And over here will be Jupiter. And Uranus beyond it, a pair of binoculars, and this. Hopefully. If we're very lucky, we'll have a heck of a thing. As I mentioned to other people, the last time I had something like this was back in 1948. The time before that was in November of 1907, I believe. So if this works out right, we are a privileged generation to be seeing a comet during totality, not the partial phases, which we're going to have out here, and we're going to have that in October 14th. AAI will be up. What, Mary? We have 3 places. Mm-hmm.
And the Turtleback Zoo and Trailside. We hope to be at those 3 locations with solar telescopes.
That's us all over. That's right.
We
And,
hope.
yeah, we hope, maybe,
Still
we'll
working
see.
on it.
But with a little bit of luck, you will be able to see a partial eclipse. I'll say it right now. I'll start the bandwagon here. When you have a partial eclipse of the sun, you cannot look directly at it. You need to have filters that are certified by the International Standard Organization, ISO. AAI is fortunate. We purchased, what is it about 900, something like that, of those filters. They're going to be on sale back here. We are not going to hit you for $50, sorry. I know you're disappointed. But you'll be able to get the proper filters so you'll be able to look. And if you got a smartphone and you got one of these clip-on telephotos, you can take one of those filter lenses, put it in front of it, close in on the sun, and get this big smile in the sky. And if you go to where the totality is, where the path of the sun over the earth is going to be, then it tells you how to use that same system with your smartphone to close in on the corona. Me, I'm going to be using my Canons, and I'll be using telescopes because I want to close in on it. But this may be what we're going to see in the sky in April 8th of next year, so stay tuned. Okay, in closing, there are great ideas undiscovered, breakthroughs available. Whoops, sorry. Oh, that's not available. Breakthroughs available to those that can remove one of truth's protective layers. There are places to go beyond belief. Neil Armstrong, and he caught it right. He's got it right. This guy was terrific, not just because he put his the first human blueprint on another world, because the guy was an aerospace engineer, he was a test pilot, and he just had this attitude that we can get this done. We just have to do it. It's a good thing to remember. So I had to put that in there because we had a meteor. And that's it. And I thank you for your attention. And good evening. Now, I always thank various people with this. Oh boy, we got a whole bunch of people in here. Hi. My wife Bonnie, who makes sure that these are all centered and the spelling is right. Mary, of course, who allows me to do this work over here. Bless you, lady. Gene and Carolyn Shoemaker, they're the ones, Gene and Carolyn. Carolyn was the astronomer, Gene was the geologist. Together they worked with David Levy and a few other people to discover comet Shoemaker-Levy 9, which hit Jupiter back in 1994. And we had this place open and rocking, waiting for it to hit. NASA, of course, gives a lot of these pictures in the European Space Agencies, our buddies, between all of us. You know, this is one thing that always bothered me. If you have these things out there, these objects that could hit the Earth, destroy life, I don't know about you, but I don't want to end up like a dinosaur, okay? And we may be the only species that this planet has created in its 4.5 billion year history that can do something about it. And we could not just, none of this nonsense where they fire off a nuke and the Minuteman IV upgraded goes out and blows it to smithereens. Well, if you do that, you're going to have one hell of a meteor shower. It's going to destroy half the Earth. So no, what we'll do is we'll blow it up to the side and push it out of the way. And we have that technology now. If we have to use it, we can use it, which I think is a very good thing to do with all these stupid weapons that we have on the planet. We have a thing about throwing rocks at each other. Then we threw sticks. Then we threw arrows. Now we got stuff that can vaporize a city. Absurd. But then you got this rock out there that could menace us. And finally, we use our weaponry and our cleverness and our tools and our spacecraft and our brains to save ourselves. Good evening.
Somebody has a question here.
Oh, okay, sure. Yeah, hi.
I just have a quick AAI advertisement. During the school year, between September and April, we have guest speakers on the third Friday of every month. One of our guest speakers, I think in January, is one of the engineers or scientists on the receivers.
Oh, cool, very cool. Yes.
Yeah, question about the Trojans and the Greeks.
Mhm.
They're at the Lagrange points on Jupiter's orbit.
That's right, 60 degrees ahead and behind.
The James Webb Space Telescope
Mhm.
on one of Earth's the ground, right?
It's actually, yes, it is. It's the one that's directly behind the moon, 900,000 miles anti-sunward. Science fiction,
Okay.
but it's true, it's out there.
Well, now, it's not just a point. Don't those objects orbit that point?
That's
Is
right,
that how that works?
that's
And
right.
is that why there's a cloud of orbiting objects rather than just all clustered together?
Yeah, well, that's the thing, Earth's gravity, we can do that trick, that Jupiter does. But Earth's gravity is so weak, it's gonna be really tiny. And maybe one of those things clipped one of the mirrors on, the James Webb, because it wasn't, it figures. You get a brand new toy, somebody puts it, you start using it, and somebody comes along and gives it a dent. Okay? That's what happened there, because one of the mirrors of the C3 tile, as it's called, took a hit. And they know it's there, so they can subtract that tile, the reflection from that tile on the telescope, from the imagery in certain cases. But that's essentially it. We got lucky. There could have been a bag of gravel waiting for it, and apparently not. So it's because Earth's gravity is so weak. Jupiter literally rules the solar system. It has such an incredibly strong gravity. It's got its own rock collection. Essentially, that's how you can look at it.
It always travels around with
Say what?
it. Travels around the sun with it.
That's right. Basically, it pulls them along. This is really cool.
Anybody else have questions here? Because then we could go online. No other questions here. Al, want to ask people who are online if they have any questions?
Okay.
Yes? Ooh,
Oh.
okay. Great.
Oh, there you go.
Okay. So ask people, anybody online from home, if they have any
Okay.
questions.
Well, if there's anybody at home, as they say, that would like to ask a question of me, please do. I think I either put them to sleep or they were. Go ahead.
I don't have a question. I have praise. Very good talk, Al. I enjoyed it very much.
Thank you. I appreciate it. We try.
Al, I just
Same
wanna-
here, Al. You do a great job every time.
Just want to mention that if you want to take a pattern is out, okay, and Jim suggested maybe you go take a look at it soon because the clouds are coming in.
Oh, great.
Not to cut you off.
No,
Al,
not at
but-
all.
yeah. But Al, I do have a question for you. You know, that picture that you had of all the asteroids and everything, which one was ours? Yeah, bring that up. I'm sure we can pinpoint one of those asteroids. Yeah, slide. Here we are. But
Okay.
anyway.
We're all
But I
we.
want to thank everybody for coming. Please enjoy the telescopes while you can before the clouds come in. And thanks, everybody.
Okay, the Apollos.
So,
Oh, yeah.
George, if you. Yes. Thank you for people online joining us.
See, these are the ones across us that just happen to be out here.
It was the movie picture that you had,
Okay.
the one slide, that showed all